Okay, so here are your notes on the families of the periodic table. First off, as usual, title a new blank page in your notes with families of the periodic table and make sure that goes into your table of contents as well. There we go. All right, so you've got access to this video. I would recommend watch at most the first 5 minutes of it, maybe just between minutes about 2 and minute 5. So the first 2 minutes tell you a little bit of history about Dmitry Mendeleev, who's the dude who developed the periodic table. He has kind of an interesting life. So if you want to watch those first 2 minutes, they're pretty interesting. But definitely watch between minutes 2 and 5. That tells you kind of how Dmitry Mendeleev developed the periodic table, his thought process behind it, some of the history of the table itself. So definitely take a few minutes to watch that chunk of the video, if not the first full 5 minutes. Dmitry Mendeleev, he did create the table in 1869. So it's been a minute. So we celebrated the 150th birthday of the periodic table in 2019. So it's a pretty old thing. Oops, do not want to play the video. There we go. So finding your way around, the first thing I want you to write in your notes, by the way, hopefully, in addition to the title that you wrote in your notebook, let me make my face a little bigger so you can see this here. In addition to having the title written at the top of your page, you should have gotten a tiny periodic table. That should be taped right about here in your notebook. We're going to be coloring the table as we go. Don't color it like what you see on the screen right here, right there. Don't color it like that. I'll tell you how to color it in a little bit. But just tape it in your notebook here, and we'll go over some details there. The first thing I want you to write underneath your table is some navigational things. So the first thing is that we call the horizontal rows in the periodic table, we call them periods. We call them that because traits repeat periodically. So there are actually 7 periods in the periodic table, and they're color-coded here. Period 1, period 2, 3, 4, 5. Period 6 starts here. It zigzags down to here. Let me move my face. So it actually goes to here, and then it catches, picks back up right up here. And the same thing with 7. Starts here, goes down here, and then picks back up over here. And we'll dig a little bit more into that in a later family, later in this presentation. The next navigational thing, so we said that the horizontal side-to-side rows were called periods. The vertical up and down columns we call groups. Often elements are grouped together based on their similar traits, so that's why we call those groups. What makes an element behave the way it does? This is a super important thing that we've talked about a little bit off and on. We've talked about valence electrons. Well, the way an element behaves is determined by how many valence electrons it has. So first off, let's go ahead and write down that definition of valence electrons. Valence electrons are the electrons in the outermost energy level of an atom. And then let's look at a couple of examples. So if we look at oxygen, if I were to ask you how many valence electrons does oxygen have, a lot of people initially tell me 8, but that's not the correct answer. Now, oxygen has 8 electrons altogether, but for the valence electrons, we're not counting these 2 right here because those are in an inner shell, and we don't care about those. We only care about the ones in the outermost shell. In the outermost shell, oxygen has 6 electrons. So oxygen has 6 valence electrons. Fluorine then. Fluorine has 7. It's got 2 on the inside, but again, we don't care about those. It has 7 in that outermost shell. Potassium just has the 1 valence electron right here. It's got a bunch of electrons all together, but only 1 valence electron. And then magnesium has 2, 1 right here and 1 right here. Those are the only 2 electrons in its outermost shell. So valence electrons are really pretty simple once you know what they are. Now, an important thing about the periodic table is that elements are often grouped in the table based on how many valence electrons they have. Elements with the same number of valence electrons will behave similarly, so they should be grouped together so that we know that these groups behave similarly, right? So if we look at this image, this shows how many valence electrons the element in that position has. So for instance, all of the elements in this first group in the periodic table, they all have 1 valence electron. It's pretty handy because this is column number 1. Column number 2, everything has 2 valence electrons. Now this group here in the middle doesn't have anything labeled, not because they don't have valence electrons, but it's not labeled because they're kind of random. There's not much of a pattern here, and so it's a little bit too complex for what we are doing in this class, but we will start back up on this side of the table over here where a pattern does pick up again. Now you'll notice on your tiny periodic table that everything that has 3 valence electrons is in group 13. Everything that has 4 valence electrons is in group 14. So they kind of match up. Notice how the number of valence electrons matches with the column number from the periodic table. So it's just something that you're going to want to keep in mind, all right? The one thing that doesn't follow this rule, as you'll notice, is right here. That's helium. Helium is the one exception to this rule. It only has 2 valence electrons instead of 8, even though it is in column or group 18. Just keep that in mind. Okay, so here's the real meat of our notes today. So this is our first family in the periodic table. Now, here's what I want you to do with this. For each family, you're going to find the name of the family. So this, for instance, is the alkali metal family. And then you're going to see a picture of the periodic table with a chunk of the table highlighted. What I want you to do is take any color and you're going to color in that group. Let me make my face bigger so you can see what's going on here. You're going to color in that group. So we went from Li down to Fr, okay? That's going to be our alkali metal group. Now, once you've gotten that filled in, that colored in your little periodic table, what you're going to do is you're going to take that same color. So this person colored that in orange, and they took that same orange color and they wrote alkali metals down on some of the lines in their notes. And then they took the following notes in just their normal writing color. What you could also do is just write the word alkali metals in pencil and then maybe underline it in that orange or circle it in orange or something. Somehow, though, you need to know that this orange here matches with the orange up here so that you know which families are which on your periodic table. Okay, you're going to do that for all the different families that we talk about. So you should have, I believe, 9 colors for these notes today, right? So once you get that colored and you get your little heading, each slide is also going to have a couple of notes about that element. These are your notes for alkali metals, for example, and you're just going to list those under there. You're going to go through all of the families, and once you've gotten your notes on all of the families, your notes will be done for the day. If you have any questions, let me know, but that's how you'll take these families of the periodic table notes.